Good morning, this is Dr. Turner with Integrated Math 3. Today we're going to be talking about 5.4, which is looking at simplifying radical expressions. If you need a little bit of review of your rules of exponents, I recommend going back to the Integrated Math 1 videos. Essentially what this is doing is combining our rules of exponents and then also adding in our newly introduced fractional exponents. So we're looking at radical expressions or rational expressions and asked to simplify them. So this is what this looks like. Just as a quick refresher, remember your product and quotient rules from Integrated Math 1 or Math 8. If you have the same base, a to the m times a to the n, let's say, your rule is to keep the base and to add those exponents. And if you are doing division, your quotient rule, your rule is to keep the base and subtract those exponents. So we're doing the same thing here, even though we have fractional exponents, but potentially we're going to have to do a little bit of fractional operation, and we may need to change the base as well. So let's say I have the fourth root of 2 to the third power times the cube root of 2 to the fifth power, for instance. And if I ask you to combine these, how do you do that? The easiest way is going to be to rewrite these as fractional exponents and then use our two rules that we just showed above. So from 5.3 rather, the fourth root of 2 cubed would be 2 to the 3/4 power, and the cube root of 2 to the fifth would be 2 to the 5/3 power. Now our product rule says we need to keep the base, add the exponents. Yes, these are fractions, but it's the same process. We're going to add the two fractions. So also as review, you can use your least common denominator, or you can use the butterfly method to combine those. If I was using the butterfly method, let's say, this would be 2 to the 3/4 plus 5/3. So you would do 3 times 3. In butterfly method, 3 times 3 plus 5 times 4 over 4 times 3. And so then you would combine. So this is 2 to the 29 over 12th power. These aren't going to be pretty sometimes, and that's okay. That's just the process that we have to go through. Okay. So number 2, let's say choose a different base here. We have the fifth root of 3 squared divided by the cube root of 3 to the 4th power. So this is our quotient rule because we're dividing. So you have 3, rewrite it as a fractional exponent, to the 2/5 over 3 to the 4/3. Our quotient rule says we need to keep the base and subtract the exponents. So we have 3, and we're doing 2/5 minus 4/3. Same thing, you can use the least common denominator, or you can use the butterfly method. So this is going to be 2 times 3 minus 5 times 4 over 5 times 3. So 6 minus 20, I get negative 14 over 15, like so. This process is going to be the same. Sometimes the bases will be a little different, and so you want to change the bases to be the same so that you can do the process. So for instance, let's say I have 4 to the 2/3 power times 2 to the 1/3. Now here we can't use product or quotient rule because the bases are not the same. However, I know that 4 is a multiple of 2. So what I would do is change 4 to be 2 squared, like so. And then using my power of a power rule, again, as a refresher, if I have a power raised to another power, that rule is to keep the base and multiply the exponents. So here, 2 times 2/3, that would give me 2 to the 4/3 power. And now that the bases are the same, now I can add the exponents. So 4/3 plus 1/3, that gives me 2 to the 5/3. Let's do another one like that. I'm going to do 25 to the 3/2 times 5 to the 3/5. Again, not the same base, so we need to change it to be the same base. 25 can be rewritten as 5 squared. Again, the goal is to make it so that the bases are the same. Once I do that, now I'm doing 2 times 3/2. That would give me 5 cubed. Our bases are the same, so I can add the exponents. I'm adding 3 and 3/5. Remember that when you're adding a fraction and a whole number, you can put a 1 as the denominator. And then same thing, use least common denominator or your butterfly method. So I'm adding 3 over 1 plus 3 over 5. If I do the butterfly method, that's 3 times 5 plus 3 times 1 over 1 times 5, which gives me a final answer of 5 over 18 over 50. Again, we're going quick through this, but it should be a review. We've covered this topic before in Integrated Math 1, and specifically we covered this topic in Integrated Math 2. If you have any questions, please reach out. Otherwise, have a good day, and I will talk to you soon. Bye.